Students, we are doing questions from Concepts of Physics by HCVERMA Volume 1, Chapter 3, Rest and Motion Kinematics. We are doing exercise, question number 15. A train starts from rest and moves with a constant acceleration of 2 meters per second square for half a minute. The brakes are then applied and the train comes to rest in 1 minute. Find A, the total distance moved by the train, B, the maximum speed attained by the train, and C, the position of the train at half the maximum speed. Students, there are two ways to do this question. As per my understanding goes, you can do this graphically, you can do this using equations of motion. So, there are certain advantages of using graphical method which you can understand when as I am explaining, and also the other method is apply the equations of motion directly. So first of all I am applying the method one which I am applying is that is the graphical method. Method one, graphical method. Students, the train is given to be starting from rest. U is equal to 0. Moves with constant acceleration. Constant. Acceleration is equal to 2 meters per second square. And you are applying, and it is going like that for half a minute. Say T1, that is equal to half a minute means 30 seconds. The brakes are then applied and the train comes to rest in 1 minute. That is, the train is coming to rest after that 30 minutes and then 60 seconds. That 30 seconds and then 60 seconds. That is 30 plus 60. That is 90 seconds. Students, we can make a graph, that is velocity time graph. Are you able to see this velocity time graph? So you are able to understand that with this graph, we can say that there is a appropriately adjusting the graph so that I can show you the timings. So this is till time t1, that is equal to 30 seconds you are accelerating, and after that you are decelerating till here t2, that is equal to 90 seconds. Till that period you are decelerating. Students, we can the train is moving, accelerating till here, and after that it is decelerating till here. This slope is given to be 2 meters per second. 2 meters per second square. This is velocity time graph, students. VT graph. This slope is given to be 2 meters per second square. Slope of velocity time graph gives acceleration, and we can also find the slope of this or deceleration by first of all we have to find out before that what is the maximum velocity it has attained. Maximum velocity it has attained can be shown by this point of the graph. What is this point? We can find out that point, the maximum velocity point, by applying equation of motion. V is equal to u plus at. Or even from this graph itself we can identify that if this is 2 and this one is 30, then what will be the height? So applying in that way, so I have this. I have to find out, let us say the vertical height is, or the maximum speed is Vmax, vertical, divided by the base 30, that is equal to slope 2 meters per second. And therefore Vmax, that is equal to 60 meters per second. So here you are having Vmax, that is equal to 60 meters per second. Next, this slope I can identify now. How can I identify? Again, slope tan theta of this tan theta. This is theta. Tan theta is equal to vertical height divided by base. Base is from 30 to 90 students. That is 60. That is 1. So my deceleration is 1 meter per second square. Why we are finding out first these students is that there are several parts to this question. The maximum speed attained by the train, that I have got now. This is the A part, 60 meter per second. Sorry, this is the B part of students. This is the B part. I got the maximum speed of 60 meter per second. Now the A part of the question is what? A part of the question is total distance moved by the train. The total distance moved by the train is this area. This area under this graph I have to find out. This area I have to find out. This area. This area I have to find out. So how to find out that? We have the appropriate base and height with us. That is area is equal to half base. Base is how much? 90. And height is how much? 60. Therefore, the total distance travel becomes 30, and this is 2700 meters or 2.7 kilometers. This completes part A of the question. Now we have to go to the part C of the question, students. Part C of the question. Find the position of the train at half the maximum speed. Maximum speed is 60. Half the maximum speed is 30. So we mark that half the maximum speed, say like this. This is the half the maximum speed. This is 30 meter per second. He is asking us the position. That means that we have to find out basically the area under these regions. Area under these regions. Which region? Till 30 meter per second. What is the area under this? And till here, what is the area? Okay. I can mark with pen, mark like this is O, this is A, this is B. Area, C part we are doing. Area OAB gives me position at first time maximum speed, first time half maximum speed. First time it attained 30 meter per second, it is going to tell that. It is attaining half the maximum speed twice. Okay. So, how to find that area? Half triangle area, base OB into height AB. AB I know very well. AB is 30 meter per second. But how to find OB? From the slope I can find out what is OB. That is, I have OA is 2 meter per second slope, second square slope. So OA is equal to slope is equal to 2 meter per second square. That is equal to, I should not write here in this way. I should simply write slope. Slope is equal to 2 meter per second square, and write slope T2 is equal to AB divided by OB. AB is 30 and OB is, I am getting through that. OB turns out to be 30 by 2, that is 15 seconds. So this time is 15 seconds, students. So applying in this, half into 15 into AB is 30. So this 2 and this cancels 15. Therefore 15 15s are 225. At 225 meters, I am going to get the first time half maximum speed of 30 meter per second. Now I focus on further areas. This is C, D, E, and I can also utilize this F, this area E. Students, what area I have to find out? Let me make it clear to you. That will give me the next half the maximum speed. That is, area will be O O C D E O. O C D E O. Now O C D E O, I can take it as sum of two areas. That is O C F O triangle. This triangle plus C D E F trapezium. I am making it again clear to you students that I am talking about this area first. With blue I am showing you this area first of all I am taking, and then this trapezium I am taking. This trapezium I am finding. That I have shown you by a small triangle and trapezium. So what is the area of this triangle, students? The area of this triangle is half base 30 into altitude 60. That comes out to be 900 meters. And now focusing on the trapezium, that is CDEF. What is the area of a trapezium, students? Half sum of parallel sides into height. Let us identify the parallel sides. We are very clear that the parallel sides are these two are the parallel sides, students. This is the first parallel side and this is the second parallel side. Now focusing on finding out the area of those we have first parallel sides, that is FC. This FC, this line is 60 and DE is 30, but I don't know this height. What is from F to E? This I don't know. How can I find out? Again by the slope I can find out. The slope I have found out to be 1 meter per second. This vertical height I know, this is DE I know. This DE I know, that is 30 meter per second. I don't know what is T to T2, I don't know. I can find out that. Carefully pay attention what I am doing. Slope is equal to 1. Slope is equal to 1. That is equal to vertical height, that is 30, divided by the bottommost position is, the bottommost position which I have is E to T2, base E to T2, that is ET2. So E to T2 will be 30 seconds. So appropriately So appropriately this time Fe will be the base F, the height. The trapezium is parallel sides are like this. Vertical height will be, this will be turning out to be 60 seconds. So F2E will be 30 seconds. So applying the logic of the trapezium, I am having now this is equal to 900 plus half sum of parallel sides 30 plus 60 into height. Don't make a mistake here, height is only 30. So this is 15. So I have 900 plus 90 into 15, that is 900 plus 1350. This sum comes out to be 0, 5, 9 plus 3, 12 and 2, 2250 meters, or I can say that this is 2.25 kilometers. Therefore at two locations, that is at 225 meters and 2.25 kilometers from the beginning position, the train is having half the maximum speed. This is a method one using graph, focusing exclusively on the graph. Method 2 is using equations of motion only, not making any graph. So let us look at that method. Method 2. Again, writing down what is given to you. Initial velocity is 0. The time till it attains maximum speed, that is 30 seconds. It stops after time t equal to total time for the beginning. It stops at 90 seconds. Its initial acceleration till this period, accelerating period, is 2 meters per second. Now, with these ideas, I can have the maximum speed as Vmax is equal to U plus AT, that is 0 plus A2 into 30, that is 60 meters per second. This finishes my B part. Now coming to the A part. A part is what is the total distance traveled in this entire journey. So how to get the total distance traveled? Distance traveled in the first accelerating period, let us mark it as S1, that is equal to distance traveled in during acceleration, that is equal to ut plus half at square. I can apply, that is 0 plus half into 2 into 30 square. So I have 900 meters. Now students, we have to find out what is the distance traveled during the S2. S2 is distance traveled during deceleration, that is equal to again ut plus half at square. We don't have deceleration, we have only initial velocity. So we can apply, but we know what is the time in which deceleration was done. So we will apply like this. S2, we can because we don't know deceleration, we can apply in this way, that S is equal to U plus average velocity into time, that is initial velocity 60 meter per second. The maximum speed here, this 60 meter per second, plus final velocity of brake stop 0 divided by 2, and time taken for the second period, that is it decelerated in 1 minute. Therefore applying that, I have 60, and using this I have 3600 divided by 2, that is 1800 meters. So now the total distance traveled is S1 plus S2 is the total distance traveled during the entire journey. That is 900 meter plus 1800 meters. That is 2700 meters. This is completes the A part of the question, students. Now coming to the B part, sorry, C part. C part is asking us Vmax divided by 2, that is 30 meter per second. He is asking us the positions. Let us say this is the way the train moved, and this is a time t equal to 0. He has covered 900 meters, and then further he has covered when he stopped at 2700 meters. So he is asking at this point the speed is 60 meter per second. He is asking somewhere here there is 30 meter per second. What is this distance? And somewhere here also speed is reducing. This is 0 meter per second finally. Here also somewhere it is 30 meter per second. So he is asking us what is this position also, students. This distance also is asking. So let us first focus on this one. Let us say this distance is S1. So let us mark this as not as S1 and S2. I will mark this. Okay, we'll mark it as S1. So S1 will be, how can I find out? I can find out by ut plus half at square I can apply. Or I have v square minus u square is equal to 2as I can apply. This is a lengthier method. I'll apply this v square 30 square minus initial speed 0, 2 into acceleration was how much? 2 into S1. So S1 is 900 divided by 4, that is 225 meters. In this way I got the distance covered in S1, that is the position at which the first time it is having 30 meter per seconds. Next time when it is having 30 meter per seconds, I can find out by using this equation, that is I will find out this distance, students, and add it to that. That is, I will first of all find S2 dash and then find S2. So S2 dash I will find, how will I find? V square minus u square is equal to 2as. I don't know what is deceleration, but there is a way to do it. What? V is equal to u plus at. The final velocity is 0 when it stopped, and its initial velocity when this brake is starting, that is 60 plus a into time taken is for the braking is 60. Therefore acceleration or deceleration is minus 1 meter per second square. So applying that here, I have v square. V square is 30 square. Initial 60 square is equal to 2 into minus 1 into s 2 dash. So this is 900 minus 3600, that is minus 2 s2 dash. So this is turns out to be minus 2700 divided by minus 2 s2 dash. So s2 dash comes out to be equal to 1350 meters. Students, this is s2 dash, but I don't have to find s2 dash. I have to find s2. s2 is equal to 900 plus s2 dash. So I apply that. S2 is equal to 900 plus S2 dash, that is 900 plus 1350 meters, that is 2250 meters or 2.25 kilometers. I hope things are clear to you, students.